Good afternoon, everyone. My name is Thomas Haver, and welcome to the Automation Firehose. Be strategic and tactical. Thank you for joining me today. We're going to be discussing how you can best implement an automation program either for your team or your organization and have it be sustainable, long-term, and successful. So to do so, I'm going to provide a little bit of background information first about myself, why I'm here today, as well as provide some context historically on the challenges that have faced automation in the past. Then I will walk through some of the framework and tooling you could potentially use, how you schedule automation into your SDLC, as well as some standards and your approach that you should take with regards to automation. I have more material than I have available time here to share today, so I highly recommend checking out the PowerPoint presentation. I've included some great information in the appendix. So to begin with myself, Thomas Haver, I work as a senior application architect. If you're interested in learning more about myself and my team, we post regularly to our blog called Red Green Refactor. I was formerly a scientist for around a decade before I joined IT. I'm also an avid board gamer. I own around 3,000 board games and travel around the world to play board games. I'm also an evangelist for Ruby Cucumber. That's sort of my primary choice when it comes to functional test automation. And I have a lovely cartoon family here. Many thanks to my wife and kids for putting up with me, especially during recording sessions at home where I need absolute quiet. So let's start with some historical context to understand why some of the challenges faced maybe 20 years ago are similar to the ones we face today. We just use different technology. So when I talk about strategy and tactics, what I mean is strategy being a plan of action or policy designed to achieve a major or overall aim, whereas tactics is the art or skill of employing available means to accomplish an end. So for instance, here with Star-Lord, he had a great strategy to defeat Thanos in the Infinity War movie. However, his own emotional tactics ended up costing his team the victory, and Thanos ended up snapping half of the universe. So the challenges that we face are not new. Taking from a blog in Microsoft way back in 2004, they had a similar problem of test coverage and how to focus their time and resources on it. We use, for example, Internet Explorer, everyone's favorite browser. Whenever they needed to make a change to Internet Explorer, the primary testing variables that they considered were the version you have based upon the service pack, the operating systems that you work on. This list grows on and on and on. So for any one change, you have dozens of combinations that you have to care about. And this is not even accounting for the 26 different language binaries that they would have to account for, making it nearly impossible across thousands of potential combinations to test everything, even for a company as large as Microsoft. So what do? At the time, they decided to implement a strategy that we know as persona-based testing, whereas they bucketed together groups of similar testing variables to represent their customers and focus their efforts in that space. It's a similar challenge that we face whether you're doing this manually or using automated validations of you only have so much time and so many resources, and so you need to dedicate them on a risk-based approach to be successful. The promise of automation has always been that it's going to save you a lot of time and lower your operational costs while raising quality. And somehow this doesn't affect project delivery time as you're trying to implement it. We don't necessarily need to agree with this sort of false promise, sometimes promoted more heavily by people trying to sell tooling. But if we again refer to something going back, say, 20 years and the promise of what test automation could bring us, that we understand for the life cycle of an application, as an application grows old, your test coverage drops and the cost and time to deliver increases because it goes from a greenfield to a brownfield application. At a certain point, if you've implemented automation, sprinkle the magic fairy dust on there, then you're supposed to have success where you increase your test coverage and you reduce the time and costs. While this sounds great, this is not simply, hey, a dividing point where we implement automation and then we're good thereafter. It's something that you commit to do long term. And you have to take the same care with automation as you would your application. Otherwise, your automation is going to have tremendous maintenance costs. So, how do we make sure that we can be successful with automation? Whenever I'm helping out an organization, I look at these primary areas to help define an automation program. What is the scope of automation? What are our objectives? What approach are we going to take to be successful? What is the framework and tooling that we're going to select? What is the environment in which we're working in? How do we schedule automation into our SDLC? And lastly, and what I think is most importantly, what is the technical skill set of the people that we are going to support and who all will ultimately own this automation? So let's start first with the approach that we want to take. First and foremost, I try to establish similarities in how different people will approach problems. I want to at least make sure that across different teams or within the same team, when you're going through and making that first determination, what should we automate, that the answer is the same regardless of who's being asked for it. So in tasking sessions or backlog refinement or discovery workshops, I like to first start with a simple checklist for people so they can understand what should we automate. Is it something that's highly repeatable? How often are you expected to execute it? Are the requirements low risk, stable, and unlikely to change? Is there a lot of human error involved if there's a lot of data entry? Does the setup take a lot of time? So these sort of questions are useful in establishing what should we automate, because you have the sort of habit of, once you are given the tool, whether it be a commercial tool or build your own, you end up trying to automate everything you can, and you should not. Just because you can automate something doesn't mean you should automate it. So first, establishing a checklist to determine viability is a good place to go with, and ensuring that it's part of a team standard. Secondly, from our approach perspective, we care about automation costs. So our test scripts should be treated the same as development code. The same care should be given for it. So if we unit test our application, great, those are automated tests, and we develop a functional test framework, then we should unit test our functional test framework as well. Every single new test script that you end up writing, factor in those maintenance costs. Every line of code you have is a commitment. Every new test that you write is a commitment to maintaining that test, because you're going to be reviewing the results. There are a lot of basic costs associated with an automation initiative, such as the tooling you select, any OS upgrades you need, any language upgrades. Additionally, you have to create documentation around the implementation and onboarding. So it's not just simply a snap of your fingers and magically you have automation in place. It's a long-term commitment. It just so happens to be an application whose purpose is to test your other application. You additionally have organizational constraints. We all understand that we're limited by delivery schedule, project budget, and technical skill set. So how do you address these sort of constraints on you? Well, this is why I say take that same approach that, say, Microsoft did 15 years ago, where they looked at it and bucketed things together and looked at what were considered to be the most risky or most important customers and test according to that. You do the same thing with your features. You want to automate based upon the frequency of use or criticality, including legal risk. You should look for complex manual scenarios that require data and environment setup. And you can end up creating what I call an automation scorecard. So I do this for multiple teams when they are ready. What we do is we identify what are the most important factors. Those end up being those columns, like critical path frequency, a legal constraint, a lot of data environment setup. Can we reuse this again and again? And then for each feature, think of it as terms of like a user story, or you can break it down further in terms of each test scenario. Either make it a simple checkbox as I have here, or you can have a true scorecard and put a scale of, say, 0 to 10 for each item. And what you end up having at the end of every single refinement or planning session is an enumerated list of what are going to be the most valuable features that you should focus automating on first, down to the least valuable. And so this will give you an area to focus your time and efforts on. anything that you do not catch at the end can be your technical debt you've accrued. Or you could establish a cutoff that below a certain threshold, you are not going to automate because it doesn't provide enough return on investment. This is another way to help standardize your approach. So what is good test automation? So to level set with you all, I believe a good test automation is there to enhance your testing rather than replacing it. You still need to think, you still need to conduct exploratory testing. It's something that should help testers do their job instead of replacing them. It's not a simple matter of we add test automation, therefore we cut all people who have the testing role on the team. It should be part of your SDLC, as in to meet your definition of done, to get your sign off, automation needs to be in place and it needs to be passing. Your scope should be beyond simple automated checks. You care about that end-to-end validation, both down across your application stack and external, whether they be third-party dependencies or upstream or downstream applications within your organization. Your automation should be focused and informative. Every single execution report that you see in review should let you know what the current state of the application is. And if you have failures, you know it's something to be addressed, which is to say automation should also be trustworthy and repeatable. If you run a suite and half of your tests fail every time you run, how likely are people to actually go back and check through those execution results? How likely are your stakeholders to actually open up that report and view it if it's sent to them via email? When people stop having trust in your test automation, then you've wasted your time. So whenever you get a failure, it should be close to a true failure, or at least you should be able to define whether it's a true failure or failed for another reason very quickly, so that way you have a short time to resolve it. Next, we move on to our framework and tooling. So this is an area that could be many talks or workshops in and of itself. But we're going to talk, say, high level about a few examples. So just one of those. So when I like to implement functional automation, what I look at is something that can also be very readable and accessible for people, especially those who are non-technical, a way to collaborate. And one of those ways is using Gherkin that you have here in given, when, then format. So given some context, when you institute a change of state, then you expect some outcome. So the top layer of your functional automation being business readable is valuable for multiple reasons. One is everyone can actually understand it. Two is your acceptance criteria become your tests. So you reduce the rewrite time. The particular example I show you here is something used for a web application. So it uses Selenium, Ruby, and Cucumber. But your mileage may vary. Just because I provide this example, I'm not saying it is the example, it's just an example. And I'll show you a little bit more what I mean about some of the tooling. Let's take, for example, Selenium. So Selenium is the most popular open source tool used for web-based automation. So why would I say recommend this tool for an organization if you have web applications? Well, for that reason is it has been implemented over and over again in pretty much your language of choice. So that means if you've got to do cross-browser testing, you can actually have Selenium implemented in the same language that your application is written in. So that means your test code should live in the same place as your development code. So you can have developer responsibility over those functional automated tests. You ideally want to try to keep your own tech stack small enough. So if you have multiple languages present, for a single application team, one is say for functional automation, another's for the actual application under test. Maybe use some commercial tooling for integration testing. You expand the scope for your team having trouble down the line of maintaining that knowledge. By keeping your tech stack small, you ensure that it's as accessible to as many people on that team as possible. So my first preference is to have the automation implemented in the same language as the application under test. Another comes down to our coding standards. So we want to spend as much time as possible having our tests actually executing and as little time spent on maintenance and sort of extending our automation suite. So if you're going to take, say, functional automation in this place, what you should do is focus on those little bits of test code. turning it into a sort of code Lego. You want it to be as reusable as possible. So on that underneath layer, when you're implementing your actual steps for your functional automation, you want them to be reusable. For instance, the user clicking on something. Well, you want to have that be written once and used thousands of times. So that way you don't have to write something from scratch each time. The other benefit of taking this approach is those little code Lego blocks can be turned into declarative statements. So whereas the imperative is very focused on UI and it's not necessarily conducive to behavior-driven development, what you can do is take those little building blocks and wrap them into declarative statements that describe, what the user is accomplishing rather than how they are doing it. So that way you keep your test cases short and sweet and everyone can understand it. You end up refactoring out the UI, so you care about the user experience itself. Again, making it very readable for everyone, reducing the amount of time you would have to spend on maintenance for a suite. So try to identify those core actions for each application type under test. For example, here with our web application, there are about 42 central user actions for how a user would interact with the browser. You can imagine and generate similar lists for services, for database, mainframe, mobile, and from those central user actions, you can end up building out those declarative steps. So you minimize the amount of time that you have to spend working on maintenance. To go even further on what is important, I'm going to save you the test pyramid and say that we care about integration and unit tests much more than functional tests. Why? Well, the integration tests run more quickly than functional tests. They're much more robust than those functional tests. They allow us to see earlier in our software development lifecycle whether or not we have failures. They're run more frequently in our build pipelines. So something that is more robust than that flaky UI that you can end up having is what you should use. And similar to the example I gave with Selenium, when it comes to tools and framework, you pretty much have your pick of the litter of whatever integration tool you want. It's going to be something, there's both open source and commercial tooling out there, and there's tooling that will line up with your tech stack already. And we take this one step further with unit testing. It's the fastest method of testing. You have easier debugging. It's highly reusable. You have a low cost to fix. And from a framework perspective, whatever programming language you use, you have the opportunity to use a unit testing framework that lines up. So again, keeping that tech stack small. So what are some common challenges? Now, I've helped out many teams and many organizations, and so these are some of the common ones that I've seen in helping out. One is the so-called automation fire hose, the name of our presentation today. So it's the approach that people take that they're going to automate everything because they have this brand new tool in place and they're going to automate just because they can. But just because you can does not mean that you should. What you should instead do is adopt that risk-based approach for automation, using the automation scorecard I showed you earlier after you've gone through that checklist to determine whether or not a test case is a good candidate. So this way you're focused on the most value-added automated tests. It's better to have a suite of a dozen tests than to have 1,200 tests that are low value. You want to have tests that always provide you the most bang for your buck. The other common area where I see people have an issue is with data failure. So if you write an automated test and say it passes in your dev environment or whatever you call your lowest environment, maybe QA, but then you start executing it again in higher environments or even potentially production and you get failures because you didn't account for the data, then you have limited return on investment for that test. Your focus should be upfront that your automated tests will execute and have the same result independent of the environment in which you execute them. And that includes full access to data. So you need to make sure your automation is cross-environment compatible. So you should have full CRUD access to your test data generation and manipulation. If you do not have access, maybe because it's a third-party dependency or an external team that won't open it up for you, that is potentially not a good candidate for test automation because you've given up that degree of control and you're going to expect to have failures because there's no test data. So test data is the most common concern, I would say, in the quality space. And you need to make sure that automation has it. Because think about this from the perspective of providing value. If you write the test once and your automation can execute across 3 or 4 environments and then execute, multiple times per day, you're getting a lot more value than having it execute in a lower environment. And if your production environment is not the same as your lower environment, then how do you really know that your automation is validating what it's supposed to? Another area where I see people commonly struggle is with flickering or flaky tests. So these are tests that you execute, and without any changes to the environment or application, they are red, then green, red, and green, flickering on and off like a Christmas tree. So if you have flickering tests, what you need to do is remove them first and foremost. So flickering tests are soon ignored by the entire team. We need them to be trustworthy. So what you do is remove those flickering tests. Those are a form of technical debt. You need to examine why they failed to begin with. It could be that your own automation scripting was bad. It could be that, again, you don't have access maybe to the data you need, or environmental issues, or the application itself maybe has some flakiness associated with it. Doing that root cause analysis will help you out. But first and foremost, if you have flickering tests, remove them. They become your technical debt and you need to pay it down. Another area where I see people run into trouble, especially with our functional automation, is long tests. So tests that are 300 steps long that validate dozens of things. These are not valuable tests. Why? Well, if you have a test that fails, say halfway through, you're skipping the rest of those validations. So then you end up losing your test coverage. How easy is it for people to read those 300-line long tests? Not very easy. So tests should be short and sweet. They should ideally test one thing, no more, no less. And your focus should first and foremost be on those unit and integration tests. Those will take priority over those long UI tests. They run more quickly, are more robust, so therefore they provide you more value. The UI-based, those functional tests are still important. They're absolutely necessary to verify the end user behavior, but you need to have UI tests that are robust and that focus on the why and not the how. So that way we mimic the end user experience. Those are true good end-to-end tests. Another area where I see people have an issue with is building automation on a shaky foundation. So you build your automation suite and you do it just to get to the end of the sprint. And every time you're developing new automated scripts, you're doing it just to get to that done state for a story. You haven't put in place sort of any long-term architectural runway. You haven't put in place the necessary controls. So automation that starts out small will end up growing large, just like any application. And that green field will quickly turn brown. So what you need to do is treat the automation code the same way you would treat good development code. You implement good practices such as dry, don't repeat yourself, KISS, keep it simple, stupid. And you schedule code reviews, code analysis, using code analysis tools, and regular refactoring sessions, which I will discuss shortly. The last issue I want to talk about is you end up lagging behind development. So we have a development sprint and then we have a testing sprint afterwards. The same thing would apply for, say, automation. No. You need to make sure that automation is part of that definition of done. You are not done until you have automation execute and it passes in an environment. So it should be, from a feasibility perspective, part of that definition of ready, and the completed scripts, part of that definition of done. Otherwise, the story is not done. This is how you make it part of your SDLC. So how do we care about getting automation scheduled in? Well, one of those areas that I think is important is example mapping. So example mapping was originally developed by Matt Wynn, he of Cucumber fame, and it falls in line with behavior-driven development, or BDD, principles of discovery, formulation, and automation. So when you're conducting an example mapping session, you focus on a single story. That's what you see the yellow card at the top. For each story, the group of people who are attending the session ideally would be, say, your business analyst / product owner, developer, someone as a tester, would discuss and identify the business rules associated with those stories. Those are the blue cards. For each business rule, you come up with one or more examples that illustrate those rules. And during the course of the session, if the team has any questions that no one in the room can answer, you write them down on those red question cards. Why is example mapping important? Well, it's a great way for us to identify business logic that's necessary to be implemented and ensure that we have test coverage via those examples because they become the user's stories. It also creates a shared understanding of the team of what is necessary from a development and testing standpoint. And through that shared understanding, we're going to end up producing rework of large or unclear stories because you can take this approach. For any example mapping session in which you have too many red question cards, that's a good indication development work is not ready to begin. So you can reject that story. If you have too many blue business rules for a given user story, that story might be too large. So what you do in the session is split that story apart into two or more and continue focusing on just a single story. If you have way too many examples underneath a business rule, that's an indication that business rule is too dense and you need to split it apart into two or more. So this is a great way for you to break down your work as you're going through refinement. So example mapping is very common. Some people will call it, say, discovery workshop or specification workshop. There's many techniques, but the important part here is you're identifying what's absolutely necessary for a test coverage standpoint. So that way you can at least guarantee that you have good coverage of your business rules. So this leads into our quality standards. So there are a number of activities that help raise the maturity of quality and automation specifically within your team. One of those is your regression review. So in a regression review meeting, you do this after every release. It can be 30 minutes, it can be an hour long. Whoever you're identifying is leading that quality effort on the team. It can be a formal title like a test lead, or it could be someone who just cares the most about the automation. They're going to compile a list of all your new release scripts and your existing regression. Your production support will provide metrics on incidents for that application for the release and prior period. Your business is going to provide metrics on application usage broken down by features so you can understand how people are using the application. And lastly, your application manager will provide a list of upcoming projects with high-level feature changes. So this way we get both the business side as well as the technical side about the future implementation. And in this meeting, you're going to figure out, all right, for our new release scripts that we've written up, what should be formally added into our core regression? What absolutely needs to be run? What in our current regression no longer provides value, either because it doesn't reflect the current state of the application or because it potentially is going away soon, or it's not an area that's highly trafficked by our users. So using this evidence-based approach will allow you to hyper-focus your regression into the areas that are going to provide you the most value. Up today, I've showed you a lot of Marvel and superheroes, but my superhero here is Martin Fowler. So here he is with a nice cape. Martin Fowler said, "I'm not a great programmer. I'm just a good programmer with great habits." And so we should adopt code reviews and refactoring in our automation the same way we would expect for our development code. So in code reviews, from an automation perspective, we want to ensure, say, that the features and scenarios reflect the actual current state of the application, that you've automated all good candidate scripts for that given story or piece of work you've done, that it's understandable by everyone on the team. So that way, if someone else is going to pick up the work, they can immediately start. And you want to make sure that you don't duplicate any new effort, that you've identified all those data needs that were previously mentioned, and you followed all the standards and practices that the team has agreed to. So in this way, we want to establish the same standards that we would expect for our development code. You should also conduct regular refactoring sessions. So in a refactoring session, you want to focus on the maintainability of your test suite, the extensibility of it as your application also grows, and spreading the domain knowledge amongst others within the team. We do so by focusing on the performance of our application, by implementing non-orthogonal design, removing anything that is duplicated to keep our suite as short and simple as possible, and by stripping out anything that's outdated. To make refactoring sessions formal rather than just an individual activity, what I recommend is You formalize it with a team leader, so someone who's going to schedule that, say, 30-minute session every week, that they're going to be responsible for any delegation of work outside of the session. They're going to choose a focus area, as well as potential any bug reports. You also should bring in someone from external of the team to be that sort of technical oracle to help the team overcome challenges if they have it, to keep track of that session, to identify action items, and have that improvement status report to show that your activities for refactoring are also providing value in the quality of your suite. Having an outside eye is similar to us conducting a code review with a peer. A peer will help you out. In this case, the peer is external to the team. For that focus area, you should select something such as a code metric report, feature item that you needed to work on, project release, potentially a regression, or a CI report. So adding this maturity in place, building in these processes will help ensure your automation is long-term successful. So in summary, what did we learn today? Well, first and foremost, that we should focus on the fastest, most robust tests. We should create UI and end-to-end tests as needed. Unit and service level tests take precedence. 2, when we're building automation, we should build based on probability of failure, impact on business, and complexity. And 3, budget, schedule, and technical skill set will always limit the path forward. So keep that in mind when selecting a tool, when scheduling in automation to be successful. So that way you don't end up wasting time on low value automation. You want to make sure that everything that you do is going to provide you the best value possible. So thank you all for your time. During the course of this session, I was in chat, so feel free to ask me additional questions or reach out to me afterwards. If you're interested in this deck, it's also located on SlideShare for you. Take care. Have a great day.